Okay, so we want to talk about sort of like families and elements and the number of bonds they will normally form. And this number of bonds will give them what we'll call later a formal charge of 0. Now, that doesn't mean they always do this, okay? But in a pinch, this is sort of a go-to thing where, okay, this is the most likely number of bonds these guys are going to form. And if they're doing this, they're most likely forming the most stable structure. And we'll talk about times when they're not doing this and how we'll determine what structure would be more or less stable using something called formal charge. But let's just talk about like some of these elements. So we're dealing with a bunch of nonmetals. We're dealing with covalent bonds, right? And when you're dealing with these covalent bonds, okay, we can sort of get an idea of just looking at shell notation how many bonds they're going to tend to form. So things that are in group 14 or what used to be called 4A have a general electron configuration which they have basically 1, 2, 3, 4 valence electrons. These, by the way, aren't putting in the right position. If I should have 2 on the top, but when they bond, that kind of changes, and we'll talk about that. Since basically carbon is missing 4 electrons to form its stable octet, things within this family will tend to form 4 bonds. In other words, if your electron configuration is 2-4, you basically need 4 more electrons. You're going to form 4 bonds. So carbon will tend to form 1, 2, 3, 4 bonds, as will other things underneath. So carbon will tend to form 4 bonds, as will silicon, okay, as will germanium. Okay, all these elements are kind of going to do the same thing because they need 4 more valence electrons. And by forming this bond, like if this is an H and an H and an H, right, coming in here like so, right? What happens is the hydrogen with its 1 electron is coming in there like so, and you got the 1 from the H and the 1 from the carbon, the 1 from the H, the 1 from the carbon, the 1 from the H and the 1 from the carbon, the 1 and so on. Now, since we're on hydrogen now, we're showing this. Okay, so general rule before we move on, things in group 14 tend to form 4 bonds. Will they always do that? No. Will we be able to evaluate structures to think of in terms of which one is more probable? Yes, we will when they don't have that octet, and we'll get to that. Hydrogen only has 1 valence electron, but it only needs a duet to become stable, okay, because all it needs to do is fill its first energy level, which can hold a maximum of 2 electrons. So hydrogen will always make 1 bond. There's literally no exceptions to this rule whatsoever. It's just a hard and fast rule. Hydrogen makes 1 bond. Period. End of that discussion. If we're dealing with group 16 or 6A, 1, 2, 3, 4, 5, 6, you can see that we're missing 2 electrons here to form the stable octet. So things that are in group 16, okay, will tend to form 2 bonds. That's why we get things like H2O, right? H, there's the O, and there's the other H. And I'm going to put the dots here, right? So this dot came from the hydrogen, this dot came from the oxygen, right? So the general rule, okay, so it's really careful pattern, very simple to understand. Carbon tends to form 4 bonds. Everything in that family tends to form 4 bonds. That's the usual thing that they do, okay? Oxygen tends to form 2 bonds. Nitrogen, which has 5 valence electrons and needs 3 more, tends to form 3 bonds. So things in group 15 tend to form 3 bonds. And if you see in the pattern here, when I get to the halogens, right, so why does a diatomic fluorine look like this? Because 1 electron comes from this, right? So I make X's for the second fluorine, right? And this is the bond. It's a pair of electrons being shared. So you get F-F with the 1, 2, 3, 4, 5, 6 with the 1, 2, 3, 4, 5, 6. And there's our dash with our 2 electrons, and that's a single bond. So halogens tend to form single bonds. Now, a little caveat coming into this thing, okay? That usually happens when the fluorines are not, when the halogens are not the central atom. Okay, we're going to see lots of exceptions to octets and things like that. However, okay, when fluorine forms a single bond like this, or a halogen does this, it's going to have what we call a formal charge of 0, which is going to be the most likely thing they'll do. But it's not a hard rule, just a general trend here. Okay, that should help you fill in really easy molecules. If someone says the formal charges on all the elements are 0, you can rest assured that what's in this column will be making 1 bond, what's in this column will be making 2 bonds, 3 and 4 respectively. Okay, short, easy video. Stop.